We're going to discuss like terms. We need two things to consider in order to determine if you have like terms. You only need like terms to add or subtract only. Please understand that. You don't need like terms to multiply. You only need like terms to add or subtract. Let's look at these two things to consider. The first thing that we need in order to be considered a like term, each of the terms must have the same variables if they're present. Now it can be one or more variables. The second thing you have to consider is that each one of those variables must have the exact same powers. With those two, you can then determine if something is a like term or not. It's not just a variable, it is the power on the variable that also makes it a like term. Alright, here's what we're going to do. I am going to give you 7x. I want you to find a like term, or a couple of them, for 7x. Now, when we do this, understand that I have a 7 times x, and the power on x, if you don't see it, the power is 1. So what I want to do is find a like term to 7x. The number doesn't matter, the variable and its power does. Now most students would normally give me like 6x. Great. Okay, fine, that's true. And most students think in the positive way. Well, what about a negative 3x? Yes, that's still a like term. It still has a power of 1. It still has an x. The number in front doesn't matter. So if it doesn't matter, what about just x? Well, yeah, it's an invisible 1 in front and it has a power of 1. So all of that still matches this. Again, the number doesn't matter. It's about the variable and the power. So I could give you something like 0.92x. That's still a like term. Again, power is 1. I could give you something like 3 over 7x. You know what? Let's make it negative. There we go. That is also a like term. What if I gave you something like x2? And that feels really weird, but you could rewrite this in terms of 2x, and that would be the same thing. I have an x, number doesn't matter, power does, power's 1. And you could also write it as in parentheses, like so. These all mean the same thing. So all of these are like terms to my 7x. By the way, not only could you put the 2 in parentheses, you could also put the x in parentheses and then rearrange it like such. So totally up to you how you want to see it. Most of the time we never see it like this. We see it like 2x, 7x, negative 3x, and so on. Very rarely do you see it in separate parentheses like that. Here is our new example. I want you to find like terms for 6xy. Well, let's go with the negatives. How about a negative 5xy? The question is that a like term, and why? Yes, it is a like term. It has a power of 1 on the x and a power of 1 on the y. The 6x, which was originally given, has a 1 on the x and a 1 on the y. Alright, so long as the variables match with the powers, the number in front doesn't matter. So you could still give me something like, 9/16 xy, or 0.085 xy, and that's fine. What if I gave you x3y? Well, let's go back to 6xy. This means 6 times x times y. Realize something here. The order doesn't matter. This is 3 in here. And these are all multiplying. Could I rearrange this? Yeah, I could write this as 3 times x times y, still having exponents of 1. So the order won't matter. I mean, you could still write this as, 3yx as well. That is the same thing. understanding that what we're doing here is we're using the commutative property of multiplication. All that matters is that the variables are there. I got an x and a y, they're to the 1 power. We normally say it as xy because it's in alphabetical order. Let's look at this one. We have negative 2x squared y. So what is a like term to this one? Hopefully you're getting the idea that you could do something like, I don't know, 0.372 x squared y. Now again, the y doesn't have an exponent on it, but it is understood it's a power of 1 if there is no power there. I have an x, power of 2, numbers in front, doesn't matter. It's all about the x squared y. Could I have also this as a like term? So this is going to be the question. Is 6xyx the same thing as x squared y? Well, let's rearrange this. This had x squared, and then it had the y second. So let me rearrange this so that I have the 6, then I put the x's here, and then the y. X times x, so long as it's times, means it gives me 6x squared y. So is this the same as the original problem? Yep, powers match, variables match, everything matches. Good to go. So finding like terms is not that hard. It's not about the number. It's matching the variables and the exponents. Now you could add these together or subtract them, whatever the directions say. So that's the idea behind like terms. Again, like terms are only for adding or subtracting only. Now that we understand like terms, let's simplify some expressions. I'm going to give you 3y squared minus 10y squared. So let's look at this. What I do when I do these types of problems is I look at the variables and I look at the exponents. Are they exactly the same? Yes, they're both y squareds. So that's just a matter now of dealing with the numbers, 3 minus 10. Well, first off, you have one's a minus and one's a positive. When you have opposite signs, subtract the numbers, taking the larger, and the 10 is, they call it larger even though it's negative, but just pretend 10 is the larger number, and then you're going to subtract 3. Now it feels like I'm going in the wrong direction, but it's always the larger number without the sign, minus the 3, and again, they're opposite signs. This is a positive 3 and a negative 10. So I'm going to take 10 minus 3 and subtract. But since 10 is the larger number and it's negative, my answer is going to be negative as well, because the larger number was negative, I'm still in the negative zone. So what is my final answer going to be? Negative 7y squared. I keep the same variable and the same power. Let's look at another example, a very classic, 17x minus 5x. In my head, I look at the variables, they are the same, so I'm just going to add or subtract the numbers. This is 17 minus 5. 17 minus 5, 7 minus 5 is 2, just drop down the 1. We end up with 12x. Since they both had an x, my answer will only have an x. Again, we're only adding or subtracting. The variable will remain the same. Power will also remain the same when you add or subtract. Alright, what happens when you got this distribution thing going on? Well, guess what? Let's do the distribution. We have the 3 times the t and the 3 times the 4. So understand, the 3 can only start here and it can only end here. Start, stop. It doesn't go any further. It does not go to the 7t. So what I'm going to do is rewrite this. I'm going to drop my sign down, as I always do. Anything in parentheses will get the parentheses. The 3 will not get a parentheses because it is positive, so I'm not worried about it. And I just simply drop down the 7t because I'm more worried about the distribution right now. So I have 3 times t plus 3 times 4. Okay, I'm going to work that out. I can't really do much on the 3 times the t, but what I can do is drop the parentheses. Since this is a 3 dot parentheses t, It's like saying times times, which is redundant, so we drop the parentheses. 3 times 4, we can multiply numbers, that gives us 12, and again drop down to minus 7t. Now, this is what we call an expression. Since this is an expression, I cannot solve for t. So understand what's going on here. If I move stuff around, the signs will remain the same in front of all these numbers. What I'm going to do is I'm just going to rearrange it. So that way I have the t's in front and the 12 in back. I'm simply moving them. I'm not crossing an equal sign. If I cross an equal sign, then these signs would change. But since there's no equal sign, I am basically just doing the following. I have 2 markers here, and I'm just simply going to move the markers here. Nothing happened other than moving them. They don't change color, they don't do anything, they just simply moved. That's all this is happening on this problem. The reason I moved it one more time is so that I got the t's next to each other. So both of these have a t, and they're also t to the 1 power, so I know these are like terms. Let's work these two out. That was the whole idea. We have 7 minus 3. Again, these two are opposite signs, so you're going to subtract. Take the larger number, in this case it's 7, if I got rid of this minus sign. So this is 7, and that's 3. 7 minus 3 is 4, but since 7 was larger and it was a negative, my answer will be negative. And then I just drop down to 12. So this is my final answer, negative 4t plus 12. These are not like terms. This needs to have a t in order for me to combine these. This is as far as I can go. Why? It's an expression. There's no equal sign. I cannot solve this. Let's go and do another problem, but let's go one step further this time. We have 5 times the quantity, b minus 3, minus 6 times the quantity, 2 minus b. Now, a lot of students get a little hung up with everything that's going on here. So here's what I do when I normally teach this type of problem. I am one of those where this gets a little crowded and too close together. So what I'm going to do is separate this, and I'm going to separate it right here, right after the parentheses. So I'm going to end up with this minus 6 here. I'm going to separate it very widely, or at least you don't have to exaggerate it like I do, but at least move over the negative 6 times here. What this does is that it forces you to work this problem separately from this problem. And then from there, once you work them out, you can smush them together. Here's what I'm talking about. I'm going to distribute the 5, which means this minus sign, as I always do, is just going to drop. So let's only work this side. I'm going to take 5 times the b, again I'm going to drop the minus sign, and the 5 times the 3. That's all I did. Anything in parentheses again gets the parentheses on it. Over here, if you want to do it at the same time, since this is a minus 6, anything negative gets its own set of parentheses. Anything in parentheses will also get a parentheses. I am simply going to drop the negative. So I have negative 6 times 2, because I distributed. Again, drop the minus sign, and this is a negative 6 times b. From here we're going to work these out. I have a negative 6 times 2, and I have a 5 times 3. I'm going to drop the parentheses here because that's just 5b. 5b, again still dropping our sign right here. 5 times 3 is 15. This side's done. Let me work this separate problem. Negative 6 times 2 is a negative 12. Drop my minus sign down. Then I have a negative 6 times b. That's a negative 6b. This is done. This needs a little bit more work. Because what you have is a parentheses with only one term inside it, you can use the double negative rule. What is the opposite of a negative 6? It's a positive 6. I have 5b minus 15. Over here I have negative 12 plus 6b. There's nothing more to do here or here. So let's put these back together again where you could have done this straight from the get-go. But I like keeping a little separate, understanding that I just separated them, and I'm going to put them together because, again, there's nothing else to do. Let's work this problem out the rest of the way. Since the 5b was in front, I'm going to move the 6. Now, notice I'm circling the sign in front because the sign in front goes with this number. The same thing goes with the minus 12. And that's not just 12, it carries the minus sign. Any sign that's in front goes with those numbers. 5b is assumed positive since there's no sign in front of it. I always keep the leading guy in front and he never moves. Since the b is in front, I'm going to move the 6 next to it, and then I'll keep these two guys together, but just kind of push them that way. Again, this is an expression, and because this is an expression, none of these signs change. I need an equal sign in order to have these signs change when I move them to the other side. There's no moving them to the other side, I'm just rearranging it. So I have 5b, I just simply move the 6 over here. Then I just push these two guys over, so this is minus 15, minus 12. So if you were to rearrange like your dresser drawer, all those socks are still there, it's just in a different order. You didn't move into another drawer, they're still in the same drawer. But now what I have are my like terms together. I got my B's together, and I got my plain Janes, my regular numbers together. Since these b's have the same exponent, we know that they are like terms, so I just simply keep the b and then add the numbers. 5 plus 6 gives me 11. Now 15 and 12 so happen to be both negative. If they have the same sign, you add them, so add 15 and 12, and that gives you 27. There's your 27. But since they're both negative, keep the sign. This is my final answer. These are not like terms. This has a B, this does not. We are done. Hopefully this answers a few questions about like terms. Again, this was a quick review. I hope this helped.